Alright, good everybody. My name is Ajaks, CEO Ajaks Tutorials, and I welcome you back to Ajaks Tutorials YouTube channel. In today's video, we're going to be looking at chemistry, Faraday's first and second law of electrolysis. So that's what we're going to be looking at in today's video. Faraday's first law and second law of electrolysis. So these are the things we are going to go through. So we're going to start with the key terminologies in electrolysis, Faraday's first law of electrolysis. We'll go through JAMB past questions of all formats. That is, every kind of way JAMB want to ask you the question on Faraday's law of electrolysis, we're going to dismantle it in this video. We're going to look at Faraday's second law of electrolysis, which many students have issues with. We're going to go through JAMB past questions on all formats of Faraday's second law of electrolysis. Then I'll give you guys an assignment to drop in the comment section. Now, before we start this video, let me tell you something. Please watch this video to the end, all right? Because knowing this alone will not suffice in your examination. You must know both first and second law. And we're going to be solving a lot of tricky JAMB questions that when you see, you fail normally, all right? But it's simple, all right? So please, what I want you to do is, if you have an earphone, an AirPod, earpiece, please use it, all right? So that you can be focused and make sure you are writing. Let's start. Now, we're going to start by defining key terminologies in electrolysis. So we're going to start by defining key terminologies in electrolysis. So we're going to start with, okay, I'm not going to write on the board, so I will reserve it for this guy. We're going to start with electrolyte. What are electrolytes? Electrolyte is a solution, or electrolytes are solution that pass through, when electricity is passed through them, they produce ions. Are you getting it? They produce what? Ions, mobile ions. So that's basically what electrolyte is all about. They are solution, all right? When electricity is passed through them, they produce what? Ions. So they are solutions that produce ions when electricity is what? Passed through them, all right? Now, electricity on electric current, anyone is fine. Now, the second terminology we're going to be looking at is electrode. Electrode. Electrode is that material, all right, through which electric current enters and leaves. Do we get it? It's the material through which electric current enters and leaves. And we have two kinds of electrode. We have a cathode and we have an anode. Are you following? So it's a material, or there are materials through which electric current pass through. That is, electric current can come in and can go out. So we have the cathode and we have the anode. Just follow me. The next terminology we're going to look at is what we call electrolytic cell. Electrolytic cell. Now, listen, this is very, very important. An electrolytic cell, this is a device. Listen attentively. It is a device that converts electrical energy to chemical energy. Is that clear? So in an electrolytic cell, note this JAMB key point. In an electrolytic cell, the anode is the positive electrode. Are you following? Good. And the cathode is the what? Negative electrode. I hope this makes a lot of sense. So please never forget this. Electrolytic cell, anode positive, cathode negative. We're not going to go in depth into preferential discharge of electrolysis. This is what we're going to just focus on. Faraday's first law and second law. But before knowing this, you need to understand this concept. All right. Now, secondly, we have what we call the electrochemical cell. So electrochemical cell now, this is a JAMB key point. Note that electrochemical cell is also called a galvanic cell. So you can say or galvanic cell. So it is also called a galvanic cell. And this kind of cell, it's a device that converts chemical energy. Listen attentively. It converts chemical energy to electrical energy. I hope this makes a lot of sense. So that's basically electrochemical cell and electrolytic cell. So in an electrochemical cell, listen, the anode is the negative electrode. Are you following? Good. And the cathode is the positive electrode. So that's basically the difference between an electrolytic cell and an electrochemical cell. This converts this one. This is a JAMB question. This one converts electrical to chemical. This converts chemical to electrical. And note that this particular cell is spontaneous. This is spontaneous. Now, listen attentively. Because of the spontaneity of this reaction, are you following? Of the reaction that occurs here, it will not have any external current flowing through it. Therefore, Faraday's first and second law is not applicable to electrochemical cell. It is applicable only to electrolytic cell. I hope this makes a lot of sense.
Ajaks Tutorials is more than just an online tutorial. It's a community built on innovation, hard work, and excellence. Ajaks Tutorials has consistently set the pace for academic success, tripling her records every year and guiding countless students into their dream institutions. In 2024, Ajaks Tutorials produced 75 students with 300 plus, with the top students emerging 9th nationwide. In 2025, the number soared to 238 students with 300 plus, with the top students ranking 8th in Nigeria. And in 2026, Ajaks Tutorials is set to do even more. Through well-structured online classes, expert tutoring, and personalized support, Ajaks Tutorials is redefining quality education. Ajaks Tutorials is headed by Ajakaye Joseph Uluwase, the CEO, founder, and a passionate educator and educational consultant, along with his powerful team of seasoned tutors. To be part of the next success story, contact us via the number displayed. Join Ajaks Tutorials today.
Now we have understood this concept. Now let's dive into our main business of today. Faraday's first law of electrolysis. Faraday's first law of electrolysis. So Faraday's first law of electrolysis. So I'm not going to write. All I want you to do is to listen to me and you write. I will dictate. All right, follow me, follow me, follow me. Now, Faraday's first law of electrolysis states that the mass of a substance or the amount of a substance, listen attentively, deposited or liberated, deposited or liberated, the amount of a substance deposited or liberated is directly proportional to the quantity of electricity flowing through the electrolyte. Is that clear? Or flowing through the solution. So that's basically what Faraday's first law talks about. Now, as a JAMB student, it's important to know the law, all right? But what is most important is to know how to apply this law and what this law says. So listen attentively. I said Faraday's first law of electrolysis states that the mass of a substance or the amount of a substance deposited or liberated. Now listen attentively. Deposited meaning mass, liberated meaning volume. So in Faraday's law of electrolysis, don't just be accustomed to mass. We're going to solve questions today, JAMB questions that has to do with the liberation of an amount of ions during electrolysis under Faraday's first law. So I hope this makes sense. It states that the mass of a substance or the amount of a substance deposited or liberated is directly proportional to the quantity of electricity flowing through the solution. Now follow me. Mathematically, Faraday's first law of electrolysis says the mass is directly proportional to Q, where Q is the quantity of electricity or the charge in coulombs, capital C. So coulombs is capital C. All right, good. So Q is the quantity of electricity in coulombs. Now listen, you need to know that your mass is in grams. All right, so chemistry, just know that your mass is always in grams in Faraday's first law. Mass is always in gram. Let me just write it. Mass in grams. Now, secondly, you need to know that Q is equal to IT. What is I? I is your current in ampere, capital A. Are you following me? Are you following? Good. And T is your time. Now, very important, in seconds. Because some questions, some JAMB questions will give you your time to be in hours. Sometimes it might be in minutes. Never forget. The proper conversion is this. 1 hour is equivalent to what class? 3,600 seconds. Don't forget this, all right? Secondly, 1 minute is equal to what? 60 seconds. So if peradventure they tell you a mass of a substance was deposited, blah, 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 for a current, blah, 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 at a time, 3 hours. So you do 3 multiplied by 3,600 before you even start solving. Don't ever forget this. So these are the key things for Faraday's first law. Now let's see questions, and I will teach you the proper formats to solve them. See, let me tell you something. See, you see this topic, it is very important to know it as a chemistry student. Are you getting me? And if you watch this video from beginning till the end, are you understanding? If you watch from beginning to the end, you are not distracted. There is no way you see any JAMB question that you are going to fail it on Faraday's first law and second law of electrolysis. All right? So follow me. Let's start. Question 1. We are going to solve 15 questions on first law, 8 questions on second law, and I'll give you assignment. All right? Let's start. Question 1. I'll give you the proper format to solve it. Now let's solve a question. Let's start with question 1. I will spend more time in question 1 and probably to question 3 because I want to explain properly. Then from question 4 upwards, you can start pausing the video and trying it on your own. All right? Good. Now let's start question 1. You're going to see the question on your screen now for Faraday's first law. Let me show this is recording. Okay, so you're going to see the question on your screen now. And in this video, I'm going to be using the normal calculator. I'm not using my scientific calculator. I'll use this. This is how your JAMB examination calculator is going to be like. All right, so this is what we use. Okay, good. Now, you see the question on your screen now. What current in amperes will deposit 5.4 gram of aluminium in 2 hours? What current in amperes will deposit 5.4 gram of aluminium in 2 hours? Given that the relative atomic mass of aluminium is 27 and 1 Faraday's is equivalent to 96500 coulomb per mole. Now listen, they gave us some things here. I will show you the format to solve these things. Just follow me one by one, okay? Now they gave us the mass of aluminium to be what? 5.4 gram. They now said they gave us these things 27 and we say 1 Faraday is 96500. Let's just leave the other guy. Now we have to find the current in ampere that will deposit 5.4 gram of aluminium in 2 hours. My time is 2 hours. What is the mass that is involved? Aluminium. So mass involved is what? Aluminium, or element involved, aluminium. Now, there are some things I want to give you. Write it in your book now. Write it in your book. I want to give you some things and I'll explain what they mean later. Just follow me. Just write this down. I will not clean it so because we'll be using it. 2. Because iron is a transition metal, it has variable oxidation number. All right. So iron can be also 3. Aluminium is 3. Okay, I think that's enough. Aluminium is 3. Okay, that's enough. I'll give you for oxygen and hydrogen later. There's something I want to do. Now, let's come back to this question. See, the format to solve this question is simple. we know that the mass is directly proportional to the quantity of electricity. So the format you're going to do is, first you say this mass, write it 5.4. We'll solve a lot of questions so that you get you understand it properly. So 5.4, you bring the mass, you equate it to, listen, you equate it to Q. You know, when you say something is proportional, it means an increase in this leads to an increase in this, a decrease in this leads to a decrease in this. So you take this mass 5.4, you equate it to the quantity of electricity from your question. Now in your question, what's the quantity of electricity here? You know, I told you that Q is IT. So the I is what they asked us to find, the current. Abi, good. So we're looking for I. Are you following me? Small. See, as I'm solving, be writing your book too. 5.4 equal to Q is IT. Current multiplied by, what's my time? 2 hours. Class, I told you that when you have 2 hours, always convert, when you have hour, always convert to seconds. So go to your calculator. 2 multiplied by 3600 is 7200, right? Good. So 7200 seconds. Now, this basically means the mass is equal to IT. You're not done now. Don't go and say to find I, this divided by this. No, you'll be wrong. You have to do a proper relationship, because this is not equal to, this is directly proportional. So you must relate it to something else for you to solve. Now follow me. After doing this, after saying the mass is equal to IT, beneath the mass here, you now come and put the relative atomic mass that the question will give you. But I feel you should know some relative atomic mass of some elements, but the question will always give you. All right, good. So 27, you put it here. You see the format now? Equal to. Now, this part is very crucial, because this part is the reason why I gave you these things. Are you following? Now, what is meant to be here? What is meant to be here is meant to be the equivalent amount of electricity that 1 mole of aluminium will give. Now, how can you do that? Why I just said is English. What you basically do is you put the number of electron that aluminium will discharge, which is 3. Aluminium always discharges 3. And you multiply it by 1 Faraday. Always multiply by 1 Faraday. And don't forget that 1 Faraday is equal to 96500. Now, sometimes you might leave this thing as, you might just put 1F. But the reason why I'm not putting 1F here is because we have to find current. So this thing now, this place is already giving us everything in coulombs. Do you understand? When you multiply the charge by the Faraday, you get everything in coulombs. So that's why I'm not just putting 1 Faraday here. I have to put the 96500. In some questions, we'll just put 1F. You'll see, don't worry. So after that, you cross multiply. 5.4 multiplied by 3 multiplied by 96500. Are you following? Equal to I times 72 times 27. Are you getting me? Are you following? So I hope this is clear enough. This is it here. Now, what will your I be finally? Let me use another marker so that you guys don't get confused. So my I will now be what? This thing now, let's multiply it. 5.4 times 3 times 96500 equal to, you get your answer, right? Divided by this thing, let's multiply it. 7200 times 27, sorry, is this 194400. Now, finally, class, what is going to be your current? Press your calculator by yourself. What's going to be your current? My I finally will be what? 1563300 divided by 194400. 4400, 8.04 amperes. And for my option D is 8.0, is approximately 8.0. All right, so that's basically what to do. All right, so in summary now, just know how it's done. You take the mass, you equate it to IT. Beneath the mass, you put the relative atomic mass, and you equate it to the number of electrons that will be discharged multiplied by the Faraday. That's constant there. That's basically how to solve it. Faraday's first law. Let's look at question 2. We'll understand properly. If you don't understand, just be following me. Okay? So before then, let me just write something down. So the whole format is the mass equal to IT, or sometimes the question will give you Q direct. But let's just put IT. Beneath the mass is the capital M, which is molar mass. So let's change it to small m so that you don't get confused. So capital M, which is the molar mass or relative atomic mass, those things in bracket, equal to small n. Now n is these things multiplied by the number of multiplied by Faraday. Okay, 96500. Okay, good. So that's the format. Then you can now cross multiply. So let's keep this in our book. This is the format we're going to use. Now, question 2. Question 2. You see the screen now. What quantity of electricity required to deposit 128 gram of copper from melting copper 2 chloride, that's CuCl2? So what quantity of electricity is required? Q. Do you understand? Now let's just go. The mass is what? 128. The mass is 128 gram, and we're dealing with copper 2 plus. So this tells us that my N is what? 2. That's the valency. That's mean of N. N is valency, the number of ions, the number of electrons to discharge. Do you understand? So what else? They gave us that the relative atomic mass of copper is 64. Then normally 1 Faraday is 96500. So what did I say the format is? We're looking for Q now. We're looking for the full Q. So what is the format? M 128 equal to Q. No more IT now, because they said the quantity of electricity. So Q, what we here? 64. That's the relative atomic mass of copper, right? Good. Equal to, now how many was N? 2 multiplied by, now we have to still use 96500 because we're looking, all our answers are in column. Had it been our answers were in farad, then we cannot put this in as 1F here. But since it's in column, and never forget that 1 farad equal to 96500. That's what is always there, 1500. So just put it here, 96500. Now let's press our calculator, guys. Quickly, your JAMB examination, don't waste your time. Cross multiply. This times this, 128 times 2 times, okay, let me not rush us. This times this is 64Q equal to 128 times 2 times 96500. Do you understand? Now, what will my Q be? My Q be this whole thing. Let's press on our calculator, guys. Let's press. 128 times 2 times 96500. This guy, Abi, divided by 64. Oh, Jesus. 128 times 128. I hate this calculator. Times 2 times 96500. I just want us to follow me. Not that I'm using scientific calculator and you're busy pressing your wire calculator. So this is 386,000 coulomb. Now from our options, we can directly see our answers. Okay, no, now many of you can't directly see it because option B and option D look alike but different powers. Now this brings us to standard forms. Now when you are seeing something like this, how can you convert this thing in standard form? See it, 386,000 coulomb. Now you take from here 1, 2, 3, 4, 5. That's what? 3.86 times 10 raised per what class? 5 coulomb. So in the answer, in the option In the option B is correct. So I hope that makes a lot of sense. Good. So now let's look at question 3. You see it on your screen now. Calculate the maximum weight of copper deposited on the cathode, that's the electrode, all right? On the cathode, if 0.2 farad of electricity was passed through the solution of CuSO4. So now that CuSO4, when it dissociates, it's going to give copper 2 plus and SO4 2 minus. So we don't need SO4 2 minus, we need just this guy. So just know that the number of electrons will still be 2. Okay? So the maximum weight, that's the mass now, Abi. So let's just write M equal to IT. So the maximum, did they give us anything like quantity of electricity? Let's find it. Maximum weight if deposited on the cathode, if 0.2 of electricity, so 0.2 farad of electricity. So they gave us a quantity. I told you that 1 farad is 96500 coulomb per mole actually, but let's go with that coulomb. Okay, so this part M equal to the quantity of electricity Q, but in this question it is given already as 0.2 F. So we don't need to now, I will advise you, don't now start stressing yourself and saying, okay, 0.2 times this. No, just leave it like that. I will tell you why later. 0.2 F. Now, what I say again, beneath it, you put what? The relative atomic mass 64 equal to, are you following me? Are you getting it? Equal to the number of electrons that copper will discharge, 2, multiplied by what? 1 Faraday. So you can see why we don't need to put this thing, because initially here I put 96500 because we have to find our answers in column. That's what the option required us to do. But in this case, we don't need that. Abi, we don't need that now. So our answers are already like they already gave us 1 farad here, so we can leave this in farad. It's fine. All right, good. Now let's solve. Cross multiply. Let's cross multiply. So when you cross multiply, what are you going to be left with? M multiplied by 2 multiplied by 1 farad equal to what? 64 multiplied by 0.2 farad. Do you understand? Now farad will cancel farad, so we're left with what? M equal to 64 times 0.2 divided by 2. Do you understand? Divided by 2. So 2 cancel this guy is 32. So my M will now be equal to 32 times 0.2. Now 32 times 0.2 is same thing as saying 32 times 2 over 10. Do you understand? 32 times 2 over 10. So how can you now do this? This is 64 over 10, and this is what? 6.4. I hope this makes a lot of sense. Hope I'm correct. 2 over 10, 64. Yes, 6.4. So 6.4 what? Grams. From the question, option C is correct. So you guys can see now, it's very, very simple. Now, question 4. Now, question 4 says, what is the mass of copper deposited at the cathode by a passage of 3200 coulomb of electricity through CuSO4, that's copper 2 10⁶, solution using copper electrode. So all these things are just English. Let me tell you, when you see Faraday's law of electrolysis in your exam, let me show this mic is on. Hold on. When you see Faraday's law of electrolysis in your exam, what you should just basically do is find these things and solve. No need for their English. This is first law. I will tell you how to differentiate second law from first law. Okay? So now, question 4. They gave us coulombs. They gave us Q as 3200. We're looking for mass. So just go. M equal to 32000. That's your coulomb. So I've done this guy. Are you following me? Beneath it, what I say you should put RAM, that's relative atomic mass, 64, equal to, now the number of charge copper will discharge, the number of electrons copper will discharge, 2 multiplied by 96500. Now we cannot put F here now, we cannot put F because this is already in column, so we have to like that. That's how it is. So solve normally again. Just solve. Solve this on your own. Fast, no time. What will M be? 64 times this. Pause this video and solve it. 000 divided by this thing. What's your M finally? Oh yeah, solve. Pause the video and solve. Let me press my calculator. 64 times 3200 divided by 2 divided by 96500. See, I'm teaching you how to use calculator. So don't go and start stressing yourself. Listen to me. Don't go and start stressing yourself and calculating this one, keeping this one place, calculate this one, keeping one place. You're wasting your time in your exam. Just follow me. 64 times 32000. You press your answer. Stay in that place. You put divided by 2 equal to divided by this. Get your answer. 10.6 is the answer. So the mass is what class? 10.6. But for my option, yes, 10.6 is correct. That's option B. 10.6 gram. You can see it's simple. So that's basically it. Now let's go to question 5. So take a deep breath. Go through everything. See if there's any issues. If there's something you're not understanding, ask in the comment section or wait till the video ends. Alright? But I hope we can solve from question 1 to question 4 and we understand it. Alright? Let's move to question 5. Okay, let's continue now. Question 5. You see the graph on your screen now. So the graph says which of the following graphs, the question says which of the following graphs represents the Faraday's first law of electrolysis. So first law says that the mass is directly proportional to what? The quantity of charge. So they're asking us that which of this graph correctly describes this particular first law. Graph A is, I don't want to really waste time on this one, but let me just explain. Graph A is basically saying that there is no change between the mass and the quantity of charge. Do you understand? That's why it is straight. There is no change. It's just the same. And that's wrong. Graph C is saying that the mass is decreasing as the quantity of charge is increasing. And that's an inverse relationship, which is wrong. Because Faraday's first law states that the mass of a substance deposited or liberated in electrolysis is directly proportional to the quantity of charge flowing through the electrolyte. Are you getting me? Good. So option C is wrong. It is meant to be directly proportional, not inversely. Option D is not correct because the mass, if you look at that particular option D graph, it is starting from the negative, which is wrong. So the only answer is option B, straight line, directly proportional. An increase in mass increases the word Q. So the answer is what? Option B. Question 6. Question 6 says, you see the question on the screen now. If 0.1 Faraday of electricity deposited 3.2 gram of copper during electrolysis of an aqueous solution, then the number of moles of copper that will be deposited by 0.6 is... Now, listen attentively. Let me tell you guys something on questions like this. This one is very straightforward. Follow me. They said if 0.1 Faraday of electricity deposited 3.2 gram of copper. So it means 3.2 gram deposited what? 0.1 Faraday during electricity. The number of moles of copper that will be deposited by 0.6 Faraday is, so first of all, this is what we have to do. We have to convert this gram to moles. Now let me tell you something on that Fridays. You know, I told you that we are going to go through all formats of JAMB questions. This is another kind of format. When we are giving moles, right, and we have to relate with Faraday, relate it straight. Note that 1 mole is equivalent to 1 Faraday. Is that clear? So the mole and Faraday have a direct relationship. So you can easily relate it. So now they tell us that 0.1 Faraday of electricity deposited 3.2 grams of copper during electrolysis. The number of moles that would deposit 0.6 is, so what we have to do is to convert this 3.2 first to mole. And remember that mass is equal to mole, that's N, is equal to, let me not use mole as N now. For many of you guys start getting confused. Let me just write it. Mole is equal to mass over molar mass or relative atomic mass. So what's the mass here? 3.2. What's the molar mass? 64. Happy? So what's my mole? My mole is what? Press your calculator. 3.2 divided by 64 is 0.05. Now this is the 0.05 mole. So 0.05 mole of copper gave 0.1 Faraday. How many mole of this same copper will give 0.6? Now, waiting did they ask you with that? You can see how I've interpreted this question. So, interpreting questions is very, very important. Okay. So, how many mole gave 0.6 Faraday? So, what you do is you cross multiply. Your X be equal to 0.05 times 0.6 divided by what? 0.1. And what would this be, glass? 0.05, press your calculator, fast. 0.05 times 0.6 divided by 0.1. 0.3. 0.3 what? Mole. You can see. Option D. I hope this makes a lot of sense to you guys. Okay? Good. Now let's look at question 7. Now, this is question 6. So question 7 says, how many kilogram of aluminium will be produced by the electrolysis of aluminium triazonitrate 5? All right, AlNO3. That's the formula. Okay, but that's not really our business. How many kilograms? So when you say kilograms of aluminium, that means the mass. But if you remember when we started, I told you that in electrolysis, your mass should always be in grams. So that's not a problem. Let's solve normally. Let's put mass. So equal to what? We're equating it to the quantity. So let's see if they gave us any quantity of electricity there. Class, I'm seeing 24 hours. Are you not seeing that? Operating for 24 hours at 400 ampere. So I'm seeing 24 hours and I'm seeing 400 ampere. So we can easily find our Q. So Q is IT, right? And Q is, what's your I, class? Your I is what? The current, which is 400 ampere, multiplied by 24 hours. So 24 hours. Now, I don't want to really waste the board. So let's do it. I told you from hour to second, you multiply by 3600. So let's first convert 24 hours to second. 24 times 3600, press your calculator. You're going to have 86400 seconds. So that's my seconds, right? So 400 multiplied by 86400 seconds. So that's basically the IT. That's IT. Okay. Now let's continue. They ask us to find the mass in kilogram. So what we will now put here is what? The relative atomic mass. So the relative atomic mass of aluminum is 27. Abi? 27. Equal to, what will now be here, class? What will be here? If you are getting it, one lollipop for you. Collect it in the comment section. So 3 multiplied by 96500. Why are we putting 3? If you ask me that question, I can smash your head. Are you following? Good. I'm not explaining. I've told you already. So 3 multiplied by what? 96500. Are you understanding? Good. So 3 is because of the aluminium is going to discharge 3 electrons. That's valency. So you add it there. So 3 multiplied by 96500. So for my mass, I can now say mass is equal to, when you cross multiply, 27 times 400 times 86400 divided by what? 3 multiplied by 96500. So let's find our mass. Press your calculator, everybody. Let's find our mass. Let me press. So 27 multiplied by 400 multiplied by, this is a very practical class, so if you're not pressing your calculator, you are doing yourself. Seriously, you have to press your calculator and you have to follow me. 27 multiplied by 400 multiplied by 86400 divided by 3 divided by 96500. So that's going to give you 3,223 grams. Now the question says in kilogram. Class, 1 kilogram is equivalent to 1,000 gram. Don't forget, 1 kilogram is 1,000 gram. So to convert this guy to kilogram, you just say how many kilogram will give you 3,223 gram. So cross multiply again. What will your x now be? 3,223 divided by what? 1,000. That's what? 3.2 kilogram. Option A. Yes, option A is correct. Option A. So I hope this makes a lot of sense. Very, very simple, very, very cheap. Let's move to question 8. Question 8.
My name is Monday Princess. I scored 346 in the 2025 JAMB examination, and my experience at Ajaks Tutorials was wonderful and very educational. They have the best tutors with the best classes that are well structured to give you the best for your examination. And I advise 2026 JAMBITES to put in all their efforts, as for sure their efforts will be crowned.
Question 8. Let's move to question 8. So question 8, you're going to see the question on your screen now. It says a current of 0.2 ampere. A current of 0.2 ampere. Sorry, 0.25 ampere flows for 16 minutes 5 seconds. So my time is 16 minutes 5 seconds. And deposits a mass of 0.163 gram. And deposit mass of 0.163 gram of a metal X. Now we don't know the metal of a metal X. During the electrolysis of an aqueous solution of a salt of the metal, what is the charge? What is the charge of this metal? So what we are looking for is that small n that we used to use before, that we know before, but now we don't know it. So you can see it's very, very important to understand all this format. What's the charge of the metal N? But they also give us that the relative atomic mass of X is 65. And 1 farad is still 96500. Now let's solve normally. So first of all, we have to work on this guy. 16 minutes 5 seconds. How can you do that? 16 minutes 5 seconds. First convert 16 minutes to seconds. 16 multiplied by 60. All right, 16 multiplied by 60. 16 multiplied by 60 is 960. See, I don't know if you guys have noticed what I usually do. You know, it's not everything that you try to use your head. Do you understand? When you say that this is something that you can easily press, it's very simple to press. Why stress yourself? Why even risk you making mistake? You can make mistake in exam tension. You can easily make mistakes. So don't go and start trying to say, okay, 6 times this on 0. No. Calm down. Press your calculator. That's why it is there. You know that it's not every time you go there, but for some time just do it so that you don't make any mistakes. Okay. So 16 times 60 is 960. Now the total time will now be 960 plus 5 because they said 9 16 minutes 5 seconds. So that's what? 965 seconds. Now, after doing that, we can now solve normally. Abi? So, what's the mass? 0.163 gram. We equate it to IT. Now, Abi now IT 0.25 multiplied by 965. Then beneath it, what we put here? The relative atomic mass as what? 65. Equal to what? Equal to what, class? This guy. So we don't know the n. I don't even know we'll put it there, but we don't know it. Multiplied by what? 1 Faraday. So 1 Faraday is what? 96500. Do you understand? If you ask me where I got this thing from, I can verse and cut this video. Everybody will go and sleep. So cross multiply. My n will now be equal to 65 multiplied by 0.25 multiplied by 965 divided by 0.163 times 96500. Now let me tell you something. Let me show you something. Let me tell you something. This cancels this. This becomes 100. Do you understand? This becomes 100. You cannot press your calculator from there. So it will at least save your time of pressing big numbers. So 65 times 0.25. 16.25 is up. Divided by 0.163. Divided by again 100. So no. Hold on. No. Hope I've not made mistake. Oh. IT. This one equal to n times. It's correct now. Let me press my calculator again. Oh. I beg go. 65 0.25 96500 divided by 0.163 divided by 100. Am I getting? Wait, hold on. Let me be sure that I'm correct though. This is 65, Abi. Hope I'm writing the values properly on the board. This question 8 0.163 equal to n times this 96500 0.2 IT 16 minutes. So that's 965 times 0.25 divided by 0.163 divided by 96500. I'm getting 0.999. So that's n is approximately 1. N is approximately what I was getting for, but I thought I'll be getting n like 2 or something. I will check the question later, and if there's any issue, I will change it when I'm editing the video. But I'm getting n equal to 1, and I'm not seeing any mistake here. My eye is that 16 minutes 5 seconds. Let's confirm that again. 16 minutes 5 seconds, or is it 15 seconds? I said 5 seconds now. 16 times 5, 16 times 60 plus 5, that's 965. IT. I is 0.25 times T. Mass here. Relative atomic mass here. N here. N times 96500. Let me, if I do my calculation again and it's still the same thing, we move on. 65 times 0.25 times 965 divided by 0.163 times 96500. The answer is 1. Okay, so that's basically the answer. The answer is 1. Maybe I was looking at this that zinc, but we move. So let's continue. Question 9. Now, question 9 is a bit more tricky because it is different from what we have been doing. So in question 9, we are going to be looking at something else. You know, when I was defining Faraday's law, I was saying something like liberated. So I'm going to do a question like that now. Now, question 9 says, what volume of oxygen measured at STP would be liberated by passing a current of 10 ampere through acidified water for 965 seconds? Now, we are using the same format. And what is format? The mass in one place, beneath it, this one, you know that format now, mass, rate of atomic mass, quantity of charge, number of Faradays. But what happened for liberated? That's when you're asking you for the volume of something that was liberated. What you do is you put the volume here, then you put the volume at STP beneath it, volume at STP. So this is equated to the normal thing, normal Q, and this one is still equated to the normal N multiplied by the Faraday. That's all. No difference. So it's the same thing we are doing. All right, it's the same thing we are doing. Now look at the question. What volume of oxygen measured at STP would be liberated by passing a 10 ampere through acidified water for 965 seconds? The molar volume of gas is 22.4. That's this guy. And the Faraday is 1 Faraday called 96500 coulomb. So let me tell you something. In Faraday's law of electrolysis, anytime you hear acidified water, note that the value for N there is 4 electrons. That's oxygen. Yes. Oxygen will dissociate or will liberate 4 electrons in acidified water. I hope that makes a lot of sense. Good. Now, when you hear Hoffman voltameter, note that hydrogen will liberate 2 electrons. Put this in your book. Good. Now let's solve. So we already know the value for N in this case, because the question said what volume of oxygen. So we know that this N is 4. Okay. So what volume of oxygen V equal to Q IT. Now what's my I? My I is 10 ampere multiplied by 96500 seconds. Sorry, 965 seconds. 965 seconds. Are you following? Beneath it here is what? The volume at STP 22.4 equal to N, 4 electrons, multiplied by what will be here? The number of Faraday, 96500. That's all. So if you do your mathematics properly, you are going to have that V is equal to, let's solve properly. Follow me. Okay, follow me. 22.4 times 10, are you getting it? Times 10 multiplied by 965 is 216160. Now divided by these two things, 4 divided by 96500. So 0.56. Now JAMB is bad. If you play with JAMB, you're gonna cry. JAMB is bad. Follow me. If you take that option, there is 0.56 cm cube, 5.6 cm cube, 56 cm cube, 560 cm cube. If you check the volume at STP you used, it was in dm cube, 22.4 dm cube. But now many of you will go and pick the answer as 0.56 cm cube. A, no, you're wrong. The answer is D. I'll tell you why. Note this conversion. For volume, note that 1 dm cube is equal to 1000 cm cube. Are you following me? Good. So 0.56 dm cube is equivalent to what cm cube? X. Cross multiply. X will now be what? 0.56 times 1000. X will now be what? 56 over 100. 0.56 means 56 over 100 times 1000. 0 cancel 0. 0 cancel 0. 56 times 10. X is what, class? 560 cm cube. Oh yeah, beat your chest and say thank God for Ajaks tutorials. Yes, thank God for Ajaks tutorials. If not, many of you would have not been able to solve this question. So please don't forget, this is dm cube. Never change your units because you want to satisfy your options. Okay? But the answer, it is what? 560 cm cube. Option D. I hope that makes sense. Good. Question 10. Another volume question. Follow me. So in case you are trying to understand this one, question 10 will make you understand properly, better. Okay? Alright, so let's look at question 10. Let's look at question 10. So question 10 will appear on your screen now. It says that what volume of hydrogen gas measured at STP would be liberated at the cathode when a current of 2 ampere is passed through acidified water for 9650 seconds. So I told you that for oxygen in acidified water, the N there is 4. For hydrogen, it is 2. Put that in your book now if you have not put it there. Okay? So let's solve what volume. See the same thing. V equal Q. So V of hydrogen equal to Q. Q is IT. Your I is 2 and your T is the time. They said 9650 seconds. Alright? Good. Beneath it, you put 22.4 dm cube. Are you following? Good. Are you following? Good. 22.4 dm cube equal to what? The number of hydrogen electron, abi? That's 2. Multiplied by, I know many of you be like, sir, but hydrogen is H plus now. I know. But in acidified water, when it dissociates, alright, it's 2 electrons hydrogen is going to give, not 1. So, you know, when you do your normal balancing, I will make other videos on balancing of redox reactions so you guys understand properly. You know, you have to still put 2 here, so account for the electrons when you cross multiply. So that's why it's 2. So 2 multiplied by 96500. I hope this makes sense. 2 multiplied by 96500. So that's it. This the Faraday. Do you understand? So don't make mistake. This is current. This one was the N. Do you get? Good. Cross multiply. So V will now be equal to 22.4 times 2 times 9650 divided by this thing. 2 times 96500. So let's, like I'm seeing a lot of like terms, no need to press calculator here. This cancels this. This cancels this. Remain 1 here. So this is 10. So 22.4 divided by 10. 22.4 divided by 10 is 2.24 dm cube. Now 2.24 dm cube, when you want to convert to cm cube, just multiply by 1000. That's all. So 2.24 means 224 over 100. That's mean of 2.24. 224 over 100. So multiply by 1000. This 1000 is because we want to convert it to cm cube. 0 cancel this 20. So it's going to be 224 times 10. That's 2240 cm cube. Option C, correct. So option C is correct. I hope this makes a lot of sense. So I hope now we can solve questions on liberated. Let's look at question 11. Alright, so let's be faster. Question 11. How many moles of zinc will be deposited by passing 5 Faraday of electricity through a solution of zinc tetraoxosulfate 6? So how many moles of zinc? So right now I told you that you can relate moles with Faraday. Okay? So how many moles of zinc? M of zinc. Alright? Let me just use MOLES. So so that I'm trying to make sure that we don't get confused with notations. So moles, how many moles of zinc will be deposited by passing 5 Faraday of electricity? So that's my Q already, 5 Faraday, through a solution of zinc tetraoxide 6. Now, how can you do this kind of question? It's simple. How many moles, X moles of this, all right, is responsible that how many moles of electricity, how many moles of zinc will be deposited if 5 Faraday was passed through a particular solution? So what we do is X equal 5 mole, then 1 mole is equal to 2 Faraday. Do you know how 1 mole is 2 Faraday? This 1 mole under is just basically saying that on your mouse, 1 mole of electricity, 1 mole of zinc will give, you know, it's N times the Faraday, and for zinc N is 2, abi? So 2 Faraday. That's basically how it was done. Okay, so 1 mole of zinc, 2 Faraday. This is normal. This one is from the question. So cross multiply. So X will now be what? 5 Faraday multiplied by 1 mole divided by what? 2 Faraday. Faraday cancel Faraday. 5 over 2 is 2.5 moles. So 2.5 moles is the answer. Question, that's option D, correct. Question 12. A current of 2 ampere, of 20 ampere is passed for 30 minutes during the electrolysis of gold. Gold is AU. And don't forget that the, what they call it? That's the charge gold will give out is 1. Okay, good. So gold is AU. So how many currents? We already have current as 20 ampere. The time is 30 minutes. Class, let's just do normal conversion. 30 times 60. That's 1800 seconds. So we don't really have time to start doing Bambiala. Abi? Good. So what else? The mass of gold deposited at the cathode is. So what's the mass of gold deposited? So M is equal to IT 1800. This now, they gave us gold is 197. Are you following? Gold is 197. We were given from the question. Equal to N is what? 1. I told you N is 1. Go and check that thing I gave you. Let me see if I haven't added gold there. Gold was AU. Okay, I not add gold. I added, it was silver added. Sorry. But gold is AU and AU is 1. So don't forget that. Gold is AU and AU is 1. Okay. So let me go back to where I was. Question what? 12. So multiplied by 96500. So just cross multiply. My M will now be 20 multiplied by what? 1800 multiplied by what? 197 divided by what? 96500. So what your answer going to be? Calculate. Now I know I did not give you gold. Sorry. Listen to what the question said. The question said gold 3 tetraoxosulfate 6. Kai, I did not see this thing well. Sorry. Gold 3 tetraoxosulfate 6 is AuSO sulfate 6. SO3. Wait, I'm coming. This is SO4 3. Just like CuSO4, copper 2 tetraoxosulfate 6. AuSO. So this basically means that this measurement AU2. So this basically means that this guy has a charge of -2 and this one has a charge of 3. So this is meant to be 3. Apologies. No way, I'm Ajaks, I'm not God. Okay, so let's continue. So this is multiplying this by 3. Now we'll get our mass to be what? What's our mass going to be? 20 times 1800 times 197 divided by what? 3 divided by 96500. That's 24.4, 24.5. Yeah. Yay! So 24.5 grams is correct. Okay? Of gold. So 24.5 grams of gold is correct. I hope that makes a lot of sense. So please, if I can make mistake, that means you have to shine your eyes in your examination. I actually did not see that AU. You know, we're just focused on solving, bringing out the parameters. So if I had seen that formula, I would have known, okay, yes, actually 3. So that's basically it. So question 13. Let's solve question 13 here. So question 13 says, what quantity of electricity will liberate 0.2 mole of oxygen molecules during the electrolysis of water? So electrolysis of water, what quantity of oxygen? So we're looking for oxygen. Electrolysis of water, Hoffman voltameter, all of them are using the same electrolyte. Okay, so that's acidified water. So what are we going to do now? What quantity of electricity? So I'm looking for Q. We will liberate 0.2 mole of oxygen. So 0.2 mole of oxygen will give us what quantity? Are you following me? What quantity? Beneath it, I told you beneath it to be the normals. Beneath it to be the normals, this guy. So this one was like X. When 5 farad pass through a particular solution, how many moles will it produce? So we did that. We now said normally 1 mole is 2 Faraday. So normally for oxygen, 1 mole of oxygen is what? 4 Faraday. Do you understand? Cross multiply. My Q will now be what? My Q will be what? 0.2 times 4 Faraday. So that's 0.8 Faraday. But from the options, all of them are in columns. So you have to convert that Faraday to 96500. So my Q will be what? 0.8 times 96500. And let's solve. What is that going to be? 0.8 times 96500. That's what? 77200 coulomb. I hope that makes a lot of sense. So that's basically it. That's basically it. So that's 15. That's 13. 13. This is number 13. That's 13 questions solved. 13 questions solved. 2 more. Then I'll give you my assignment. I would have given you guys the 2 more in the comment section. Let me see if they are hard. Alright. Okay, I'll give you the 2 in the comments. Yes. So let's see. We solved 13 questions. I'll give you the 2 in the comments. Okay. So I'll give you 2 plus extra 3. That's making 5 classwork for you for first law. So I'll put it now after I finish this part. So take a break, then move to second law. Okay. So I'll put the assignment, solve it before moving to second law. Okay. I'll put it there now.
My name is Bukola Johnson and I had 349 in the 2025 UTME. My experience in the UTME was so beautiful. The classes were very amazing. The tutors, they were very dedicated to impacting knowledge in us. It was truly a very competitive environment. We had bi-monthly mocks. Me that I thought I would be topping it all the time. I even got 12th position. It was so beautiful. My advice to 2026 JAMBITES is for you guys to enroll early so you can experience the full features of Ajaks room properly for the 2026 exam. Wishing you luck.
Alright, so welcome back, guys. Now let's look at Faraday's second law of electrolysis. So in the previous section of the video, we have treated Faraday's first law of electrolysis, and we have gone through down past questions, and I hope we have attempted our assignment. Now let's look at Faraday's second law. So what we are basically going to do is, I'm going to explain the law. I'm going to give you all the ways JAMB can ask you, that's the format JAMB can ask you, then I give you an assignment. Okay, good. Now Faraday's second law of electrolysis states that, right, it states that if the same quantity of electricity is passing through different electrolytes, then the mass of the substance liberated or deposited is directly proportional to the chemical equivalent. Is that correct? So it is directly proportional to what? Chemical weight equivalent. Now follow me. Now what this basically tells us is that in second law, we'll be having 2 electrolytes, 2 or more electrolytes safe. But what's happening is that the same quantity of electricity is passing through them. Now, if you recall in first law, we established that how you can solve it is first of all saying the mass is equal to Q, then saying here as the relative atomic mass equal to what? The number of electrons multiplied by what? Faraday, right? 96500. Now, this is a bit different. In second law, it is saying that if you have an electrolyte and the same quantity of electricity is passing through, let's say for example, let's use Br2, PbBr2, lead bromide, all right, and potassium chloride. If the same quantity of electricity is passing through them, what can happen is that we can solve normally for one electrolyte, get our Q, and use this same Q for the second electrolyte. That's Faraday's second law. That's basically it. Now let's see a question, a JAMB question. Question 1, you see the question on your screen now. In the above setup, so the setup is showing you AgNO3, that's silver nitrates, and CuSO4. So in the above setup, a current was passed for 15 minutes. My time is 15 minutes. So a current was passed for 15 minutes. So my time is 15 minutes. So this is question 1 we are solving now. Oh yeah, quickly convert. 15 minutes to second is what, class? 900 seconds. It should not be new to us now, be good. So 15 minutes and 4.32 gram of silver. Pay attention. Silver. 4.32 gram was deposited on the cathode of AgNO3 cell. What is the mass of copper deposited on the cathode of CuSO4 cell during the same period? Now, it's funny, right? They are giving us information for silver and they're asking us information for copper. This is second law. So in first law, you don't be dealing with one electrolyte. They'll mind their business. If they give you for copper, you have to find for copper. But for second law, they can give you for silver and you have to start finding for oxygen. Are you getting it? So that's how to differentiate first law from what? Second law. Okay? I have to be sure that this is still recording. Alright, so now let's look at it now. Let's solve properly. So I said in the above setup, a current was passed for 15 minutes and 4.32 gram of silver was deposited at the cathode. What is the mass of copper deposited on the cathode of CuSO4? So first of all, let's find the quantity of electricity that passed through AgNO3 solution. Let's find the quantity of electricity that passed through it first. Now, we'll solve it normally. What's the mass? 4.32 equal to, I'll be very fast because we have done first law. 4.32 equal to what? IT. What was the current? Oh, we don't even need current because we're looking for Q here. We're looking for the quantity of electricity that passed through the solution, so we don't need those things. So Q, beneath it is what? 108. That's the relative atomic mass of silver. Equal to this place. Silver is 1 now. 1, right? So 1 multiplied by 96500. Do you understand? Now when you cross multiply, you'll be getting Q to be 4.32. Just press your calculator. I'll give you the answer straight now. 4.32 times 1 times 96500 divided by 108. That's 3860 coulombs is the electricity that passed through AgNO3 solution. But second law told us that when the same quantity of electricity is passing through them, then the mass is directly proportional to the chemical equivalence. Now, the chemical equivalence basically tells us that we can equate this and use still the same thing to find for copper. So let's find for copper, CuSO4. Doing the same thing, we're looking for the mass of copper equal to this Q. Normally, you know, it's M equal to Q, so we're using this Q now. You see, in this case, we did not use the Q because we're looking for it. Now I've gotten it, we use this Q for the copper. Unit here is 64. Equal to 2. Copper has 2 electrons now, right? 96500. What's your M going to be? Give me straight, give me straight, give me straight, give me straight. Press, 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 press. You first me calculating it, one lollipop for you. 64 times 3860 divided by 2 divided by 96500. That's 1.28 gram. That's the answer. Yes. So 1.28 gram of copper. So that's basically how these things are done. That's how second law is calculated. Question 2. A quantity of electricity liberates 1.5 gram of aluminium from its ion. The mass of silver, you can see, they give us aluminium information, but they're asking us for the mass of silver. The mass of silver that will be liberated from its ions by the same quantity of electricity is. So it is simple. What do we do? What do we do? First, the mass 1.5 for aluminium equal to, we don't know the quantity. Are you getting it? Unit aluminium here is 27. The unit of atomic mass equal to what? Aluminium is 3 electrons times. Now, I want us to do something. Let's leave this as 1 Faraday. So that we'll have Q in terms of Farad. So, like this, if you don't understand, please put column. Please, I beg. I beg. If you don't understand, just put column. So, Q equal to cross multiply 1.5 times 3 divided by 27. Now, this thing is your Q. So, I put Faraday. So, Q will now be what? 1.5 times 3 multiplied by 27. Divided by 27, I mean. That's 0.16 Farad. That's your Q. Abi? Now, they said this same Q is what will pass through silver. So, we're looking for the mass of silver. M of silver is equal to this Q. And what will be here? 108 equal to how many? Silver is 1, Abi? 1. Multiply by F, just 1 Farad. Cross multiply. M will be equal to 108 multiplied by 0.16 Farad. Are you following me? Are you getting it? I hope you are seeing the board. Divided by 1. So my M finally is equal to 108 multiplied by 0.16. 17.28 grams. This is the answer. That's approximately, okay, in my own, I'm seeing 18 there. But I remember this was meant to be 0.167. So this was meant to be 167. So if I'm saying 167, by 108, that's 18. So let's just put as 18. 18 is actually the answer. I did not approximate properly here, but I hope you get the gist. Okay, now let's go to question 3. Question 3. Let me clean the board. Okay, so let's continue. So question 3. Now question 3 says if 6.4 gram of 6.4 gram of copper is deposited in a copper coulometer connected in series with a Hoffman voltameter, the volume of oxygen liberated at STP is. So what they're basically saying is it's connected in series. If it's connected in series, then the same current will flow through them, your current electricity. Do you understand? So first, let's find the current that flew through. That flowed through this coulometer. I don't go tabo abego. So 6.4, your mass equal to Q. This place is what? 64 equal to copper is what? 2 times 1 farad. Let's leave everything as farad. You understand? We're big boys now. B. So Q equal to 6.4 times 2F divided by 64. So 6.4 divided by 64 means 64 over 10. So this 6.4 means 64 over 10. So I'm crossing this. I'm left with 2 divided by 10. 2 divided by 10, that's 0.2 now. Be 0.2 farad. I hope this makes sense. Good. Now, what else? The next said is connected in series to a Hoffman voltmeter. So what we just did now was the coulometer. Now the next part is what? The Hoffman voltmeter. And don't forget that the electrolysis here, the electrolytes here is acidified water. And in acidified water, oxygen gives out 4 electrons. Don't forget that. Don't forget that. Good. So it means that my N is 4. So my N is 4 for oxygen. For hydrogen, I've given you this thing before in case you forgot. For hydrogen, my N is 2. I hope this makes sense. Good. So so let's solve. So we're looking for the volume of oxygen if both of them are in series. So volume is equal to Q 0.29 0.2 farad. This is 22.4 equal to what? This thing is 4 because oxygen now multiplied by what? 1 farad. Cross multiply. V will be equal to 22.4 times 0.2 farad divided by 4 farad. So farad cancels farad, then farad cancels farad, then I want us to do this with that calculator. Just look at me. V will be equal to this 22.4, just leave it like that first, multiplied by, okay, hold on. So where can I write this thing? So V is 22.4 multiplied by 2 over 10 multiplied by 1 over 4. That's this 4 here. Farad. Farad will cancel farad already. So let's solve normally now. 2 here 1, 2 here 2. 2 here 1. 2 in 22.4 is 11.2 divided by 10. 11.2 divided by 10 is what? 1.12. Just take the 0 to the other side. DMQ. If you don't understand, please press your calculator. I hope this makes sense. Good. So the answer is 1.12. Option C. Question 4. Let's look at question 4 now. Let me clean the board. So for question 4, this is very, very sweet. This one is very, very sweet and simple. They said, what is the molar ratio of electrons required to discharge 1 mole of Ca2 plus and 1 mole of Al3 plus? So what's the molar ratio? What's the molar ratio? Now, the molar ratio, that means we have to find the mole of each of them. So let's start. For Ca2 plus, how many mole molar ratio of electrons required to discharge 1 mole of these guys? So molar ratio of electrons basically means the farads. So 1 mole of this guy gives how many farad? If only normals, 1 mole of this guy gives, no, not farad, electrons. Or let's leave it as farads. If only normals, 1 mole of this guy gives 2 farads. Cross multiply, what's your X going to be? That's going to be what? 2. Right? 2 electrons. Now, for Al3 plus, 1 mole of Al3 plus gives how many? If 1 on the normals gives 3, X is what? 3 electrons. So if you now do your ratio, you're going to be getting that the ratio is what? 2:3. That's the answer. Option A. Good. Now, question 5. Because we are solving JAMB questions. Good. Question 5. In the above experiment, a current. Okay, no, you guys should try it on your own. Try this one. Put in the comment section. I want to solve question 6 and 7. You try question 5 and question 8 by yourself. Put in the comments now. I'll put it there. I'll put it on the screen now. Solve question 5 and question 8. Put it in the comment section. Now let's solve question 6 and question 7 together. 6 and 7. This is money. Good. You see on the screen now. If the cost of electricity required to deposit 1 gram of aluminium is 4 naira. So 1 gram of aluminium, the cost of electricity required to deposit it is 4 naira. How much would it cost to deposit 24 grams of copper? But this is 3 plus. How much will it cost? X. It's very, very simple. Like mad. Follow me. Follow me. Let me show you. Let me show you how you do it. Follow me. Now, this question, I saw it first in my life when I went to a competition then in my secondary school. I don't see the question. I saw it, some of my mates were solving it. I was like, waiting with this. Cost of electricity in Faraday again. Alright? Now, this is what the question is saying. They said if 1 gram of this costs 4 naira, 24 gram of this will now cost how much? How can you do it? You can never relate mass to naira directly. You can't do that. You have to relate the farad, that's the quantity of electricity that passed through this guy. That's what you have to relate with the naira. Now, let me explain what I mean. 1 gram as the mass equal to Q. This place, what's aluminium? 27. Equal to what's here? 3 times farad. Let's leave it in farad. Cross multiply. What's your Q, class? Your Q is going to be what? 3 farad divided by 27. Leave everything like that. Just leave it. Everything is in columns. Leave it like that. Now, it means that this is what gave 4 naira. Now, let's do the same thing for this one. 24 equal to Q. What's beneath it? Copper. Copper is what? 64, abi? Equal to 2 times F. What's Q going to be, class? 24 times 2F divided by 64. Class, what's this going to be? This one here, 32. 2 here, what? 16. 2 here, 12. Abi? 2 here, 8. 2 here, 6. 2 here, 3. 2 here, 4. So this is going to give me 3F over 4. Abi now? Good. 3F over 4. Yes, equal to X. That's the relation. Now, you cross multiply. When you cross multiply, you'll be having 3F multiplied by how much naira equal to 4 naira multiplied by 3f. Don't forget to put your over 27 over 4. Do you understand what I just did? See, this multiplied by this multiplied by this. I hope this makes sense. Now, let's solve normally. You can see what's cancelling out. 3f is cancelling 3f. We're left with what? X over 27 equal to 4 will cancel 4. Equal to what? 1. Approximately, my x is what, class? 27 naira. That's the answer. Option A. That's the answer. So, I hope this makes a lot of sense to everybody. I hope it makes a lot of sense. 27 naira is correct. And this is how to solve cost of electricity in Faraday's law. I have one more cost of electricity problem. I will solve it here, but I'll give you one as assignment. So you push up dropping on my assignments in comment section. Dropping it. Just dropping it. You drop it like this. Faraday's first law. Answer. Question 1. Like that. Okay? So now let's solve this last but not the least question. So it's the last actually. Let's solve the last one. Question 7. Then we close this video. Like, subscribe, share to your family. Question 7. You see it on your screen now. How much will it cost to deposit 16 grams of aluminium? We don't know the amount, Abi. If 1 gram of this same aluminium, this is actually first law question. If 1 gram of this same aluminium costs 4 naira. Now, how can you do so? This one is simple. It's simple. This is what it's basically saying. How much will 16 gram cost if 1 gram costs 4 naira? Remember I told you, never ever you relate gram to cost. What do you relate to cost? Q. So, let's solve this one. Let's find the Q for here. Then from there, we'll not be able to relate to this one. So let's solve the Q here. If I will solve the Q for both, let's solve the Q for this one first. 1 equal to Q. Do you understand? What will be here? 27 for aluminium, 3 multiplied by the Faraday. What will your Q be? Cross multiply. 3 divided by 27 F. That's 1 over 9. 1 over 9 F. Right? Good. Now, for this part, we have done for this one. Now, let's do for this one. Okay, no, sorry, we have done for this one. Now, let's do for this one. 16 Q. 27. 3 times F. Are you following me? Q will now be what? 16 times 3 times F divided by 27. 3 here, 9. That's 16 over 9F. Now, 16 over 9F and 1 over 9F. Now, let's relate properly. They said this will give how much if this gives this. Now, what was 1 correlating to? What was the quantity of electricity for 1? F over 9 or 1 over 9F. Let's go F over 9. Is what gave 4 naira. Are you following me? Now, this will now give how much? 16 over 9F will now give how much? That's it. So let's go cross multiply 16 over 9 F multiplied by 4 naira equal to F over 9 multiplied by X. 9 will cancel 9. F will cancel F. What will be left with? X is equal to what? 16 times 4. And what's your X class? 64 naira. That's the answer. So from what we have in our options, option C. Okay, so guys, we have come to the end of this video. I hope we enjoyed this video. It was a long stretch. I'm even tired, but I hope you enjoyed the video. And please, if you have any question, feel free to ask. All right. And if you want to learn more about Ajaks tutorials, this is my number on WhatsApp. It's on the screen. text me on WhatsApp. You can visit the description, visit all our platforms, follow us there. Ajaks Tutorials and online tutorials centered at providing quality lectures for students preparing for JAMB examination, post UTME, WAEC, GCE. Just text me on WhatsApp to enroll and have the full features of Ajaks Tutorials. I remain Ajaks, see you at Ajaks Tutorials, and have a lovely day. Bye.
Ajaks Tutorials is more than just an online tutorial. It's a community built on innovation, hard work, and excellence. Ajaks Tutorials has consistently set the pace for academic success, tripling her records every year and guiding countless students into their dream institutions. In 2024, Ajaks Tutorials produced 75 students with 300 plus, with the top students emerging 9th nationwide. In 2025, the number soared to 238 students with 300 plus, with the top student ranking 8th in Nigeria. And in 2026, Ajaks Tutorials is set to do even more. Through well-structured online classes, expert tutoring and personalized support, Ajaks Tutorials is redefining quality education. Ajaks Tutorials is headed by Ajakaye Joseph Uluwase, the CEO founder and a passionate educator and educational consultant, along with his powerful team of seasoned tutors. To be part of the next success story, contact us via the number displayed. Join Ajaks Tutorials today.